In this problem, we're given a diagram, and we're asked to find x as a function of k. What this means, before we get started, is that in this triangle, the value of x, we suspect, will depend on what the value of k is, which on its face isn't that surprising. Let's think about it before we start the algebra. If this diagram is drawn to scale, and it does appear to be, I mean, the 30 and 45 degree angles do have some general resemblance to what a 30 and 45 degree angle would look like, then x would appear to be a little bit larger than k. And it shouldn't surprise us to find out that if k was 10 inches, that x would be a certain value bigger than 10. And if k was 1,000 miles, that x would be something bigger than 1,000 miles. And so, of course, it seems clear when you think about it that x will depend on k, or in other words, that x will be a function of k. That being stated, when we're told to find x as a function of k, we're asked specifically to find a formula, x equals something in terms of k. To do this, I've decided to use the law of sines. I can't, by the way, use SOHCAHTOA or the Pythagorean theorem here, can I? Because I don't have a right triangle. I don't believe that third unstated angle would be 90. No, it wouldn't. And so, being that I don't have a right triangle, my only two ways really to make a formula out of this triangle, to find the relationship I want, is to use either the law of sines or the law of cosines. Those are my two general non-right triangle options. I could try the law of cosines as well, but for some reason I decided to try the law of sines, and it worked out nicely. Watch as I show you the algebra. Setting up the law of sines here, you'll notice that the angle, the sine of the angle is always over the side opposite of that angle. In other words, the x is opposite to the 45, and the k is opposite to the 30. So this is a proper setup for the law of sines. The next thing that I did to simplify matters is use what I know about the unit circle to get the values of the sine of 45 and the sine of 30. Now you may be more accustomed to the unit circle in radians. We haven't worked much with degrees in relation to the unit circle, but 45 degrees is pi over 4 and 30 degrees is pi over 6. So you should be able to find these two unit circle values, so to speak. The next thing I decided to do is cross multiply. Here's the result. Hit pause if you need more time. The next thing I decided to do to simplify the equation is to multiply both sides by 2. And when I multiplied both sides by 2, lo and behold, I had the result, or I got the result that I wanted. Notice at the top of the screen, it tells us to find x as a function of k. That's precisely what I've done in the bottom equation. I found x in terms of k. By the way, it's worth noting that radical 2 is about 1.41, which you didn't need to do for this problem, and you could only do that with a calculator anyways, unless you had it memorized. But it brings up something interesting, and what it says, to me anyways, when I look at the bottom line in the algebra here, the approximation, to me that means that x is 1.41 times whatever k is, or restated, x is 41% larger than k. And if you look at the diagram, I think that that's logical. Whatever k is, x will be larger by about 41%. Now, if you didn't understand the meaning of the decimal and all that, that's fine. You could have answered the question without that. Here we have x in terms of k, and therefore we have x as a function of k. And that completes this problem.